We're going to talk today about inverse variation. To do that, we're going to go back and remember what direct variation was. Direct variation was something that could be written in this format right here. Okay? We also said that you could find the k, the constant of the variation, by taking every y value, dividing it by the associated x value, and that would give you the same number over and over again. So we could tell that something was direct variation if it can be written in this format, or from an ordered pair if we took them and divided the y value by the x value every time it gave us the exact same value, or from the graph, because a direct variation was a line that goes through the origin, through 0, 0. So today we're going to talk about inverse variation, and you'll notice the difference is the placement of the x. Instead of the x being multiplied times the constant is divided by the x. If I were to take this and multiply both sides by x, I would get x times y is equal to k. So you can tell if something is an inverse variation, if it can be written in this format or this format. Okay, it's normally this one. And again, it just has an x and a y and one other number, and the constant number is divided by the x. We can also, so here are the two formats. Now you can find the constant of the variation by multiplying the x and the y together. Just that simple. Multiply the x and the y together. So let's take a look at these. Ready? 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. Since 1 times 3 is 30, 2 times 15 is 30, and 3 times 10 is 30, then we know that the k value is equal to 30. So yes, this is an inverse variation. And if we were to write to the equation, we would say y is equal to 30 over x. Okay? In this case, 1 times 5 is 5, 2 times 10 is 20, 4 times 20 is 80. So this would be no. This is not an inverse variation. You can also tell inverse variations by their graphs. Now, one thing that you will notice is that because k is a non-zero constant, that means your x value and your y value cannot equal, either one of them can equal 0, cannot equal 0. That also means that they'll never be on the x or y axis. You can identify inverse variations by their graphs. Now, notice the red graph here. It's actually two pieces, okay? And we said that the x and the y value could not be equal to 0. So you'll notice that this gets closer and closer and closer to the y-axis here and here, but it never touches it because the x value cannot equal 0. All right, same thing going this way. It gets closer and closer to the x-axis, but never touches it, and the same thing here. So this is a standard graph for an inverse variation. Notice that the k value is 1. If the k value increases to 5, it's still got the same look to it, but it's further away from the center. If the k value is negative, it takes this red curve here and flips it over or reflects it over. So it would be this purple one here and this purple one here. Okay? You'll notice that it never contains the point 0, 0 because x cannot equal 0 and y cannot equal 0. So they can never be solutions to an inverse variation. Okay, so here it says write and graph the inverse variation in which y is equal to 0.5 when x is equal to negative 12. So we're going to kind of review all of this together. To find the k value of an inverse variation, you're going to multiply the x value times the y value. And in this case, that's going to give you k is equal to negative 6. To write the equation for this, it's going to be y is equal to negative 6 over x. And then to graph it, you need to plot some points. Now, again, we said it's never going to contain 0, 0. Since the k value is negative, we know that there's going to be a curve here and a curve here. And because the k value is a little bit larger, it's going to be out here. So really and truly, all I need to do is get enough points to figure out what's going to happen here. All right? So my equation is y equals negative 6 over x. If I put a 1 in here for x, then I get a negative 6 for my y value. So 1, negative 6, 1, 2, 3, 4, 5, 6. All right. If I put a 2 in there, I get a negative 3. If I get a 3 in there, I get a negative 2. If I put a 6 in there, 1, 2, 3, 4, 5, 6, I get a negative 1. Okay, that's going to give me enough to draw that part of the graph. Now I need to see what happens over here. If I put in a negative 1, I get a positive 6. If I put in a negative 2, I get a positive 3. If I put in a negative 3, I get a positive 2. And if I put in a negative 6, I get a positive 1. And again, that's going to give me enough. Oh, that's kind of crooked there to get that graph. Okay? Inverse variations is one of the simplest form of rational functions, which is what we will talk about next.